We're now going to consider the monopolist's situation in a bit of detail. Specifically, we want to think about how the monopoly is going to be able to maximize profits. Let's start with some simplifying assumptions. First, we'll assume that the firm knows the demand for its product. That makes life a lot simpler. Of course, in the real world, firms can only guess or estimate what their demand is. The problem that the monopolist has is to choose a price. And once that price is chosen, then that's going to automatically determine how much the monopolist is going to sell and what the monopolist's revenues are going to be. So it's really just a choice of picking a point on the demand curve. And the point that we'll assume the monopolist is going for is the price that's going to maximize its profits. Also going to make the assumption, at least for now, that there's just a single price that's going to be charged for all customers. Later we're going to consider a more interesting situation in which the monopolist might be able to charge different prices to different people. I should add that the analysis that I'm about to go through applies to any firm that has some market power, that is, that can choose the price of its product. So while I'm going to be talking about a monopoly here, the logic, the framework that I'm setting out and that's set out in the text applies to firms in those other two market structures that we just saw as well, monopolistic competition and oligopoly. I'll just have a very simple numerical example here, which I'm going to go through quite quickly. I'm going to go through it quickly because first there's a parallel numerical example in the textbook, and as well I can go through it quickly because if you want to look at it in more detail, you can just pause the slides. So I've set out the basic information that we need. The firm knows that if it if it sets different prices, which I've set out here, it knows that it can sell varying amounts of output. So in order to sell more, it needs to lower its price. That's just follows from the downward sloping demand curve. We can figure out what total sales revenue the firm would get just by multiplying the price and the quantity. So that gives us this column here. And we can ask, how much extra revenue does the firm get by lowering its price and selling a little bit more? So that's the definition really of marginal revenue. How much extra revenue do you get by selling an extra unit of your product? And as we've seen, to sell an extra unit of your product, you need to lower the price a little bit. So we can just see that as we lower the price, revenues are going up, but by smaller and smaller amounts. That's just the value that's shown here. And eventually, if the price gets low enough, we're selling a greater quantity that we can see over here, but the price times the quantity actually starts to decline. So our extra revenues become negative. So why is that happening? Let's understand that a little more clearly by looking at a picture. So let's just look at the demand curve in this simple case that I've illustrated in the table. So if the price is $11, 1 unit is going to be sold per period of time. If we lower the price to $10, then we sell an extra unit. I want to describe what's going on here in terms of a price effect and an output effect. And what do we mean by that? Well, when the price is lowered, then the unit that we sold before for $11 is now being sold for $10. That helps to reduce our revenues, in this case by $1. That's the price effect that comes about as we sell an extra unit of our product. But, of course, as we sell an extra unit for $10, that helps to increase our revenues, in this case by $10, as shown by this light blue rectangle. So if we put those two together, the output effect of the price effect of -1, the output effect of +10, we have our marginal revenue of $9. That can be seen by just looking at our total revenues here when we're selling 1 unit for $11. So our total revenues are 11. And if we lower the price to 10, then total revenues, just the area of this rectangle, are 20. So 20 minus 11 is 9. So that's the net addition to our revenues. I can keep on doing that for different prices and quantities. So if instead I said, suppose we lower our price from $9 to $8, what happens? You can see that there's a price effect here. So we lower the price from $9 to $8. Before we were selling 3 units. Now we've lowered the price by $1, so we lose the $3 on those units. But we sell 1 extra unit now for $8. So that's an output effect of 8, a price effect of -3. The net effect is +5. That's our marginal revenue in that particular case. Your text doesn't use these terms, price effect and output effect, but I think it helps to understand exactly why marginal revenue keeps changing as we move down the demand curve. So in general, what's going to happen is that marginal revenue is going to be getting smaller and smaller. In these 2 examples I've given, we've seen marginal revenue is declining. And that's happening because the price effect, which is negative, is getting bigger and bigger as we move down the demand curve. And the output effect, of course, is getting smaller and smaller. We're selling additional units of output, but for a lower and lower price. And that's why eventually marginal revenue becomes negative. The price effect, in other words, dominates the output effect, and total revenues start to decline. If I just graph the values that were in that original table, I get a picture that looks like this. So the demand curve describes the different points, price and quantity combinations that the firm can sell at, and these red dots that I've connected here form a straight line that describes marginal revenues. Just point out this one spot here where marginal revenues go from being positive to being negative. At one point right there, marginal revenue is 0. What does that mean? Well, that just means that the price effect, which is negative, as we've seen, is just exactly counterbalanced by the output effect. So if we imagine that we can sell fractions of a unit here, then the extra little bit that was produced and sold right around here didn't bring the firm any extra revenues. The marginal revenue was just 0. What that means in plain English is that revenues are maximized there. Now, a lot of students kind of get fixated on that point. They think, oh yeah, maximizing revenues, that sounds good. But the firm wants to maximize profits. So it's got to think about revenues minus its costs. That's the key thing. So we need to consider costs as well. So let's bring costs into the picture and see exactly what costs are relevant here. So I'm going to draw a picture that now incorporates the idea of demand and marginal revenue that we've just gone through, and I'm going to throw in a story about marginal costs. I'm not going to bother explaining or trying to tell a story about why marginal costs look like this. I could have just as easily drawn a picture where marginal costs were constant instead of increasing. Wouldn't make any difference. But let's just go with this. Basically, I'm doing that so that I'm not deviating too much from what's in the text. All right, so what we need to think about is we need to compare marginal revenue with marginal cost to figure out where should we produce and what price should we charge. Let's see how we should be thinking about that. At any rate of output to the left of what I've labeled as Q star, marginal revenue is greater than marginal cost. There's a gap there. That means that if the firm produces a little bit more, it adds more to its revenues than it adds to its costs. That must mean that its profits are increasing. And that argument is going to continue to hold right up to this point here. If we go anywhere beyond that, the additional costs are greater than the additional benefits. In this case, the benefits of additional revenues. Well, this, of course, is a familiar kind of argument in terms of comparing marginal benefits and marginal costs. So the firm is going to maximize its profits right where the addition to its revenues is just equal to the addition to its costs, but it doesn't want to go anywhere beyond that. So this is the optimal quantity to produce. What price do we want to charge for that? Well, we want to charge the highest possible price that our customers are willing to pay. And the demand curve gives us that information. So what I've labeled as P star is going to be the profit maximizing price. What can we say about this outcome? Here's the standard textbook story. I'm going to comment on this in a moment. The standard textbook story says monopoly is inefficient. Why? Well, from a social point of view, we would like to produce where the extra benefit that people are getting from the good is just equal to the extra cost to society of producing that good. Now, again, to keep things simple, I'm assuming that there are no externalities here. So that's the argument for why this is the efficient quantity, QE. It looks like it's where marginal revenue is equal to 0. That is just an unfortunate coincidence in terms of this picture. So there's no necessary connection there. Well, you can clearly see that the monopolist has chosen to produce less than that. So that's not good, according to this argument, because by producing less, that we are, as a society, giving up these extra benefits that would have more than counterbalanced the extra costs of producing this additional quantity. And so the monopolist chose not to do that because it was interested only in its own profits. So the area that I've shaded in green shows that loss of social benefits that we could have had, or net benefits. So really what I'm doing is comparing monopoly with the situation of supply and demand, or perfect competition, which would have given us that efficient outcome. What's happened with monopoly? Well, the monopolist has raised the price above what it would have been had we been at this point here. It's left consumers with a smaller consumer surplus. So instead of consumers having a surplus equal to this big triangle here, they've been left with this smaller triangle that I'm outlining in this way. The monopolist has captured A in terms of the higher price compared with the competitive market, and the consumers have simply lost that surplus shown by B because now they've got less to consume. Compared to the competitive situation, C is also a loss of surplus. It would have been producer surplus before. The monopolist doesn't mind losing that because A is much bigger. So we end up with that net welfare loss of B and C. So there's our loss again. Well, I just want to spend a moment dumping a little cold water onto this. The analysis that's in the textbook is standard. It's in all textbooks, and it makes these assumptions. It's really assuming that we can compare the competitive market and the monopolistic market by assuming that demand is unaffected by whether the market is monopolistic or not, and it's also assuming that marginal costs aren't affected. But we really would want to ask ourselves, is that true? After all, it could pay a monopolist to advertise and to attempt to move market demand, obviously to increase it. We could also ask, would costs be the same if we had just a single large firm producing the product compared with a situation where we had many small firms? I think obviously the answer is no. You would expect costs would be affected. So if that's the case, the simple textbook comparison between these two market structures really is not right. So it's not much of an argument for saying that monopoly is inefficient. I'll just let you read the textbook for other arguments about either the benefits or the costs of monopoly. Those include the idea that monopolists might use their profits to innovate and create new products, but it also suggests that it's possible that monopolists could get lazy and they could allow their costs to increase. It could also be that they corrupt governments by lobbying them to protect their monopoly powers. Let's now go on and consider some more interesting pricing situations.